Hello and welcome back. Alright, in the last video we took a look at the basic definition of what a graph is. In this video we're going to go ahead and implement a very simple graph. And let's get started. So I just have a plain simple basic C++ app that I created in Xcode. So go ahead and do that. The first thing we're going to do is we're going to need to create two classes. One of those classes is a node class, and the other one is an edge class. So I'm going to do this all in one file just to keep it nice and simple. So our first one is class node, and I'm going to just create a public field for now on this class, and I'm just going to give it it's going to be a character type, and it's going to be called name. And then I'm going to create a constructor for this class. That's going to pass in a C. And then I'm just going to use this type initialization syntax, which just makes it easier or a little bit cleaner to set the name field on the node class with the variable C. So it's node parenthesis char C parenthesis colon name of the field you want to initialize, parentheses, the value you want to use, and then I just have two empty braces over here because functions need curly braces for their implementation. And in this case, node does nothing. Alright, so now we're going to need our next class, and that's going to be the edge class. Oops. Okay, and so we're going to create two properties here. Remember, our edge needs two nodes, so we're going to call one start and one end. Doesn't really matter. Actually, I'm going to go ahead and call it A and B. That way there's no meaning necessarily involved. So we're going to use a node reference. We could use a pointer here, but all edges need to have a edge, or all edges need to have two nodes, so we can use the reference. That way we can make sure that there's never a null value on our edge. Alright, so we have node A, and then we have a node B. Okay, and then I'm going to do the same thing. I'm going to create a constructor just so our sample is a little bit easier. Node, we'll go ahead and call this X, and node Y. And we will initialize it, A with X, and B with Y. And again, an empty function body. Alright, so there are our two classes. Okay. So I'm also going to use this other fancy thing called a vector. A vector is a built-in type for us, and that vector is essentially a dynamic array. So kind of like the linked list example that we did, a vector is just going to give us a way to store the information that we want to go ahead and take a look at. All right, so got to preface it with standard vector, and vector is a templated class. So what that means is that we can tell C++ that there's a specific type that's associated with a vector. Don't worry too much about that right now, but I'm just going to put inside this angle brackets an edge pointer, edge star, to say that, hey, my vector called graph holds edge pointers. Okay, I hope that makes sense. All right, so we're going to go ahead and need to create all of our nodes. So we'll call node A and pass in a character A, node B, pass in the character B, node C, pass in the character C. We can do node D too as well, I guess. Okay, so we have all of our nodes. Now we've got to create our edges. All right, so edge between A and B, so we just pass in AB. Let's create an edge between A and C. And we will create an edge between A and D. And then we'll also create an edge between B and C. Alright, so now we have all of our edges. At this point in time, we essentially already have all of our graph, but we don't have an easy way to iterate over that. So that's what I'm going to use this vector for. So what I'm going to do is call graph.pushback is the function that you call to put something at the end of your vector. And since I need to pass in edge pointers, I'm going to pass in the reference to AB. Okay, and then we do pushback, reference to AC, graph.pushback, reference to AD, graph.pushback, reference to BC. Okay, so now the next thing we want to do is we actually want to iterate over that vector and go ahead and output basically the relationships in our graph. And so to do that, we need to create this thing called an iterator. An iterator is simply, it's basically a pointer inside the vector that traverses the vector and gives you back each one of those edge pointers that you've put back in there. So the syntax is going to look pretty scary, but it's really pretty straightforward. So we need to scope it with standard vector. We need to say, hey, you know what? The vector that I'm using is an edge pointer vector, so I need to create or denote that here. Then I do another scoping, and I do iterator. So what that tells the compiler is, hey, I want an iterator that knows how to walk vectors of edge pointers. Hope that makes sense. And we're just going to call this IT. And now we're just going to do a simple for loop. So for, we'll say it equals graph.begin, which is the function that gives the beginning pointer into the graph for our iterator to use. And we're going to do this until our iterator equals the end of the graph. And so the end is this function that gives you back the ending location so that the iterator knows when it's actually done. And then we need to increment our iterator. And so those two lines of code actually have a lot going on in them. The iterator, the IT++ right here, it makes use of C++ operator overloading. I don't think we've talked about that at all. Basically, C++ gives you the ability to redefine how you do certain things. Let's just leave it at that. All right. So we'll talk about that more later on in this series. So with that, let's just go ahead and say, hey, this iterator thing just kind of magically works here for us. All right. So now we need to get an edge pointer. I'm going to call it E. And now our iterator is this pointer inside this edge vector. So the way that I actually get the actual edge information is I dereference my iterator. So basically that travels, remember that pointer tail? That travels from the pointer up into memory into the location of where that pointer is pointing to. All right. So we got a lot of stars going on there, but that's okay. And remember, we're storing edge pointers inside. So when I dereference my iterator, which is really a pointer into my vector, it's going to give me back another pointer to an edge data structure that I passed in. Okay. I hope that makes sense. And so now what I'm going to do here is I'm going to output a little message. We'll say edge, and then E, dereference. We want to do a.name, and we'll draw a relationship. Actually, it's non-directed, so let's just go ahead and it's non-directed. Let's just draw a dash. A, and then we need to do b.name. And then at the end, we'll just create a new line. Okay, so I know this iterator piece probably is really complicated, but just kind of bear with that piece. The important part of what's going on is right here. We created our nodes, we created our edges, and then we just added them to a vector so that we could iterate over them later and print them all out. So let's go ahead and build this and see if I messed up anything. Perfect. Let's go ahead and bring up our command window. Oh, earlier testing. I always forget to clear that log. Go ahead and run. All right, and here we go. We have our edge A, B. We have our edge A to C. We have our edge A to D. And we have our edge B to C. Pretty straightforward. All right, so really that's it. If we want to create more edges, we can. No problem. We can create an edge from, let's say, B to D. Add that right in here. And then add B to D. Build and run. Rerun it. And then you can see our new edge gets added right there. And you know, we can take them away. No problem. Run, A, B, and we have B, C, B, D. So that's our simple implementation of our graph. A few tricky things, I guess, kind of brought up. We brought up this way to initialize member fields. I could have done this as well. Just said name equals C. That works. That works as well. It's just a little more clear that, you know, name is actually a member. So let's go ahead and initialize it that way to get rid of any code that actually, any logic that may actually be in Node that's going to need to make use of those fields. All right, so the tricky parts right there were those initialization fields and this iterator stuff. So I apologize for that, but the graph piece is pretty straightforward. You just create some nodes, just like we had, and edges. So in the next video, we're going to go ahead and take a look at what we can add to our edges to make some of our graphs more interesting. But with that, all right, thanks.